A lot of circuits need a split power supply, and in the past I used to use a lot of 9-volt batteries, and it was really easy to make a split power supply. You just directly connect the positive side of one battery to the negative side of the other battery. That becomes your ground, and then the other ends, this battery would have the negative 9 volts in relationship to ground, whereas this battery will have the positive 9 volts in relationship to ground, and you would have 18 volts across all of it. So this video, we're actually going to use my 18 volt bench power supply. That's the maximum voltage it can output, and so nicely that works to giving us a 9 volt split supply, 9 volts positive, 9 volt negative, and we're going to use a 741 op amp to actually split that, and it's really easy. And so here's the circuit we're going to be building. Really straightforward. So we have a voltage supply, and that's going to be the 12 volt one. I have these alligator clips here, and there's alligator clips that come from the power supply, my bench power supply. I'll just clip those together. That will come up later. But first off, we need a voltage divider at the non-inverting pin. So that will be how we set our voltage. And the 741 op amp, the pin layout is like this, and a lot of op amps have the same pin layout, but make sure you find the right one, the right data sheet for the one that you're using. And so there's the non-inverting input. That's pin number 3. So like all dual inline packages, the numbering starts top left. There's a divot, and looks like, yeah, this one only has the center divot. It doesn't have the little one to the right there, but to the left I mean. But if you see that little left one and not that one, that's still up to the top there. So that's pin number 1, and you work your way down, and it stops at 4 down because there's 8 total pins. You jump across and work your way up, 5, 6, 7, 8. So pin number 3 is the non-inverting input. As you can see here, that's where we set the voltage divider. So we're just going to take 100 kilo ohm resistors, and ultimately what this is going to do is we're going to have 18 volt power supply. So this will set 9 volts at the non-inverting input pin. So there we go. I just have the one that goes to the negative rail nestled in between this one, but I have space here so we don't short circuit the power rail. But they can touch over there, of course, because they're going to the same pin. And now all we have to do is add one more thing, and that is a jumper that goes from the output to the inverting pin. And output is pin 6, and the inverting input pin is number 2. I should say the inverting input, not pin, but not the inverting pin. But there we go. It's a little jumper I made, and it goes right over the integrated circuit. And literally, other than powering it up right now and taking multimeter measurements, we are done. So there's the meter ready to go. We have the red alligator clip here. The bench power supply is not on yet, but we'll clip that there. And we don't have to worry too much about short circuiting anything out, because I can limit the current that the bench power supply supplies. And so now it is on, and it is set to 18 volts, which we will verify with the multimeter here. Scoot this up, and we will take measurement there. So just a tad bit below 18, but pretty much spot on 18. That's good enough to say. And it's an auto ranging meter. All we have to do is set it to voltage and make sure the red probe is in the right spot, which it is for measuring everything but high current. So in any case, we just got the rail voltage. So if we do kind of the normal thing where we keep the black probe here to the negative rail, then we'll see at the positive rail, as we just measured, we'll have 18 volts, and this comes to the output there, 9 volts there. So this is the halfway point right here, 9 volts, as you can see there. We can also go over here, and now it's -9. And that's actually how you measure it, except for usually where you consider ground, which is the 0 volt reference point. That's where you put the black probe. And then now when we go to the positive rail, it is a positive 9 volts, and if we go to the negative rail, it's a negative 9 volt. So now we have a 9 volt split power supply where we have 9 volts positive and 9 volts negative in relationship to this point. So we can build other circuitry over here that will use this as ground instead of one of these rails as ground. And I also indicated on the schematic here that we have the voltage divided by 2. So 18 divided by 2 is 9, and that's positive. And then down here, so the negative rail, that was the positive rail. Negative rail, we have the voltage divided by 2, so that's 18 again divided by 2 is 9, but it is negative, so a negative voltage, and that's in relationship to ground, our 0 volt reference point. So now to visualize things, I have a couple of LEDs, and we're going to do these first two LED circuits. So we're going to think of the output here as a current sink. So that means that current's coming in from a positive side of the power supply. That's just how they used to think electricity was in the past, and now we know electrons actually move from more negative towards more positive. But when we talk about current, we still talk about current as if it is positive moving to negative. So we want to sink current. So the current sink is going to be the more negative side of the circuit. We're going to put the cathode there, as you can see there. The anode we're going to put away from our current sink. So we're going to put it down one row. Let's zoom in so we can see that a little easier right there. And now the resistor is going to go to the positive rail right there, and it's 9 volts higher than our ground, so positive rail, and we will see the LED turn on just like that. And now let's, instead of thinking of the output as a current sink, let's think of it as a current source. So now it's going to be more positive, and the LED will go to the negative rail. So I'll pluck this resistor out, and now we'll put the LED to the negative rail. We need to put the cathode. Again, the cathode needs to be towards the more negative side of the circuit. The anode, the longer lead, towards the more positive side of the circuit. Right there. We'll plug that in, and we'll close this gap with the protective resistor. And there you can see the LEDs on. So this is a 1 kilo ohm resistor, and it's plenty for protecting an LED from 10 volts. And so we could either use the output as a current sink or as a current source. And all that really means is that its 0 volts is sometimes lower than a power supply, and it's sometimes higher than a power supply. And now we're really going to combine those two circuits into a polarity indicator circuit. So we're going to use a jumper here to connect to a voltage, and based on whether it is less than 1.6 volts from the 0 volt reference point or more than 1.6 volts from the reference point, 0 volt reference point, we'll be able to know the polarity of that voltage. And so let's zoom in to get a better look. And first we're going to use the blue, or wire up the blue LED I should say. So anode is going to go towards the 0 volt reference point, because we want this to light up when there's a lower voltage. So blue is going to kind of indicate negative. So the cathode goes down one row there. And now let's shuffle this over. So we're going to put the red LED parallel, but it's going to have the opposite polarity. So we want the red LED to light up when our jumper, we're going to use the probe, is more positive. So we're going to put the anode down here, and the cathode we want this to light up when the cathode is more negative, of course. So that's going to go to the 0 volt reference point. And so it's just flipped the other way from the blue LED. And then we just have to attach the jumper, and that's about as close as I can zoom in, and hopefully you can see that pretty well right there. I'm just going to stick it right in the middle there. And now if I touch the red rail, red LED comes on, so we know that's more positive than our 0 volt reference point, the output there. And blue rail, the negative rail, the blue LED lights up. We know that's more negative than the output there. And blue LEDs seem to be really bright. I've noticed that. So this is a brand new red LED. It's still quite a bit more dim. And I got some that I abuse too that are a lot dimmer than these new ones. But in any case, that's really it for this circuit. I've been trying to come up with the best way to make a rail splitter, and I really had that option all along. I just had to, I bought a bunch of these UA 741 op amps, like 20 of them, and this is all I had to do to get a split rail for other op amp circuits. So in any case, hopefully you enjoyed this video. Thanks for watching. I will see you in the next one.